Hi there, I'm Rebecca Weaver. We're going to look at the chain rule today, which is section 3.2, very powerful rule for taking derivatives. It involves the composition of functions. This is a useful way of combining functions f of x and g of x is to replace each occurrence of the variable x in f of x by the function g of x. The resulting function is called the composition of f of x and g of x and is denoted by f of g of x. So let's look at an example of composition of functions. Suppose we have f of x equal to x minus 1 all over x plus 1 and g of x equal to x cubed. What is f of g of x? Well, that means we need to replace each of the x's in f of x with g of x. So we're going to replace each occurrence of x in f of x by g of x to obtain f of g of x equals g of x minus 1 all over g of x plus 1. Then we would get, replacing that g of x with what it actually is, the x cubed, would get x cubed minus 1 all over x cubed plus 1. The chain rule. This is it. I mean, this is a powerful rule, really fun rule. To differentiate f of g of x, differentiate first the outside function f of x and substitute g of x for x in the result. Then multiply by the derivative of the inside function. So we're going to look at this as inside and outside functions. What this is, notice the derivative of this function composition is, take the derivative of the outside, leave the inside alone, all times the derivative of the inside. I'm going to be saying that over and over again. Here I go, one more time. Take the derivative of the outside function, leave the inside function alone, all times the derivative of the inside function. So let's look at an example. We're going to use the chain rule to compute the derivative of f of g of x. F of x is going to be equal to 4 over x plus x squared, and g of x is going to be equal to 1 minus x to the fourth. So we need the derivative of both f and g. So we take each of their derivatives using our traditional rules that we've been using, mostly power rule and the sum rule there. Then I need to figure out what f prime of g of x is so I can fit that into my rule. So I will take my f prime here, and wherever there is an x, I'm going to replace it with this g of x right there. So let's look at that. F prime of g of x, notice it's negative 4 over, wherever there was an x, I now just insert this g, so it's 1 minus x to the fourth all squared, plus 2 times what was once an x is now a g, so I'm going to write in that g. That is 1 minus x to the fourth. Then I'm going to substitute everything into the chain rule, and this is what I get. Yes, that can be simplified a ton, which is what they're going to have you do in their homework as well. So it's algebra from there. But that's the main part of the chain rule. So let's look at another example. Let's compute dy over dx using the chain rule. Notice that y is not a function of x here. Y is equal to the square root of u plus 1, and u is a function of x. Now you could, if you wanted to, go ahead and put the square root of 2x squared in for u, and you could take that derivative. That's one way to get dy over dx, but it wouldn't be using the chain rule, so we're going to do what they say, but it's probably what I would do if I was going to take this derivative. Now, since y is not given directly as a function of x, we cannot compute dy over dx unless we substituted this 2x squared in for u. Then we could. However, we can differentiate with respect to u to the relation y equals the square root of u plus 1, and we can get dy with respect to u, take that derivative of y with respect to u, and I would get 1 over 2 square root u plus 1. Similarly, we can differentiate with respect to x, our relation u equals 2x squared, and we will get du over dx is 4x. Using the chain rule, dy over dx is dy over du times du over dx. Notice that the du's cancel there. So what I would get is just 1 over 2 on to the square root of u plus 1 times 4x. Now you're probably not going to want u's and x's in there, so what you're going to want to do is substitute in your 2x squared for u, and this would be what they would want really at the end. So let's look at a word problem. Marginal cost and time rate of change. The cost of manufacturing X cases of cereal is C dollars, where C equals 3x plus 4 under the square root of x plus 2. Weekly production at T weeks from the present is estimated to be X equals 6,200 plus 100 T cases. They're going to want us to find the marginal cost. Marginal cost is just C prime. Find the time rate of change of cost. This is C prime, but with respect to T. Marginal cost is C prime with respect to X. Notice. How fast with respect to time are costs rising when T equals 2? All right, let's see if we can work through these. Now, first up, we're going to look at C of X, and we're going to figure out what the derivative of C is with respect to X. So we're just going to take our cost equation and differentiate that with respect to X. And we'll get 3 plus 2 over the square root of X. Next, if we want to figure out what the derivative of C is with respect to time, we're going to use the chain rule. So we have our dc over derivative with respect to x. And now we take the derivative of x with respect to t. So we take that x equation that they gave us in terms of t and find that derivative is 100. Next, we're going to use the chain rule. Derivative of c with respect to t is derivative of c with respect to x times derivative of x with respect to t. Notice those dx's cancel. And I'll just multiply those two quantities together. And then we will be sure and put in, for our x, we need to put it in terms of t because they wanted dc over dt. So that was what we did next. And then we would simplify this. It doesn't really simplify a whole lot. We could distribute that 100. I probably would go one step further and write it as 300 plus 200 over. But for, in essence, of keeping this a little shorter, that we're not simplifying. So with respect to time, when t equals 2, we just take that equation that we just found, that derivative of c with respect to t, and just plop in a 2 everywhere. And so I just did that computation for you there, and I got 302.5 cases of cereal per week. And that is the end of section 3.2. If you have any questions, be sure and email me. Y'all have a fabulous day.